week is we're going to basically like build some kind of simple app together. Partly just to bring together some of the stuff that we've been talking about, partly just because it's nice to see, okay, but concretely if I was going to actually, like write some software in Haskell, how would I actually do it? So, we'll actually talk about stuff like the package management system and like, how you put together an actual project. Also, I'm hoping that some of it may be useful for those of you that are doing a final project. If you're building some kind of app, that some of this may be certainly welcome to use anything that I show you, obviously. Let's actually make a bigger terminal to start. We're just going to start. So I'm going to make a directory. I don't even know. Well, I have an idea to start, which is like the kind of classic guess the number game where the computer picks around a number and you like guess and it's like too high, too low. And that's probably not going to take us the whole week, so we'll like start with that and then we'll generate some ideas. We'll just see where it goes, and we may end up with something totally different, or we may end up with like a super fancy version of guess the number. I don't know, but that's kind of my initial direction. And I'm happy to, I don't necessarily have like a set place I want to get to. So whatever ideas you'll have, you're like, hey, could we do this? We can talk about it. So I got an entry directory. What you all have done at this point would be like to start by creating a .hs file, but I'm not going to start by doing that. So I'm going to start by so there's this. Have we used cabal? Have we talked about this at all? Have I ever told you to use it? Okay, cool. So cabal is well, two things. There's a library. Well, it's really three things. It's like a format for describing a Haskell package. There's also a Haskell library that anyone can use. That if you wanted to like read .cabal files or like do stuff with that format, you could use that library to do stuff. But then also there's actually a tool, an executable tool that you can use to do stuff with packages. Okay? So it does a whole bunch of stuff. So you can use this like to install packages, to build packages that you're creating. It'll do stuff like, if you want to install a package, it'll automatically figure out what other packages it needs and go download them and install them too, all that kind of stuff. Okay. So I'm going to use, there's something called cabal init. And lots of options. So basically it creates kind of a skeleton project for us. And fun story, I can't help but tell you that like this part of Cabal, this tool, this init tool, was actually me and someone else that together wrote this initially, but it was many years ago. We were just kind of like, hey, it'd be really cool if Cabal had a thing like this, and so we just made it, contributed it. It's an open source project. At this point, probably most of the code in there, probably none of the code that I wrote is still there. It's been rewritten multiple times, and things have been added and changed. But I don't say that to brag. I just say that to be like, I saw something that could be improved, and I just was able to contribute some code to that. All right, so we're just going to say cabal init. Are there any of these options that we want? I do, yeah. I think by default it's not interactive. It just if you just say cabal init, it just makes all the choices for you and just creates it. But I want the interactive version, so no, I actually don't. Okay, we are going to build an executable. The main module, main.hs, sure, sounds good. Probably most of the defaults are going to be fine anyway. Package name, package version, I don't really care. 0.1 is fine. Choose a license, okay. Usually use EST3+. Doesn't really matter. Sure. Email. Don't have a URL. what kind of features are enabled by default, so that's fine. Sure, we'll add some comments to all the fields. So it made a bunch of stuff. It made like a changelog file, which the idea is like whenever you make a release, you put in here like what changes happened since the last release, and the package can kind of automatically display this file. There's a license, right? I chose a particular license, and so it copies the text of that license in there, like with my name in there. So, well, I want to look at this yes.cabal file, because we're probably going to need to edit this later as well. Whoa, it got fancier since I last did that. That's cool. Okay. So, okay, so link to documentation. And I chose to put comments in explaining every field, which is why it's got all these comments. If you're like familiar with these, you could just say no, and it'll just like, it's just a configuration of the comments. But, so like if we wanted, we could put a longer description here and uncomment this. In particular, I'm going to scroll down here. So here, this is the part that we might need to edit later. So notice it says, all right, our main file is main.hs, and then here's where it says, okay, here's some packages that we depend on. So right now we only depend on the base package, which kind of you always get. But I think we're going to end up wanting some other packages from package to do different things, and so we'll need to add them here so that when it's building our package, it knows, oh, we need that one, so we should go download it. And if other people try to build it, it'll automatically get those. That's really the only part I think we're going to need to edit right now, but obviously there's other stuff in here, and you can read the documentation. So, all right. What else is in here? That's really it. And then there's the app directory, which just has our main.hs. Right. So, what is in here? Did it already fill in something? Or is it just blank? Okay. It's just made a main for us. So we should be able to run it, and it should print out hello Haskell. So yeah, I think that the simplest way, we can just use Cabal to build and run it and everything. That's probably the simplest for now. If you're working on bigger projects, so I particularly like this tool called Stack that I think you all have used to install stuff. It doesn't matter whether or not. Stack in particular does stuff like you can like specify the exact versions of things that it's going to work with, and it'll automatically download the right compiler for you and all this kind of stuff. So if you want to have a big project that anyone can build themselves and be guaranteed that it's going to work easily, that's a nice solution. But for now, we're just going to. So I should be able to say like Cabal build. Oh, because I'm in the app directory, so it's like, what do you, the guest.cabal file is here. Right. So it's building it, built it, right. And so then I should also be able to say, so I could say Cabal install if I want, and that will like copy the executable file to somewhere where I could just run it directly. So for now, like it built it in, this is the directory where it put executable, right? It's like, it's like in some like private directory that, where it's just putting the outputs of the build, so it's not going to mess up anything else. But we can tell Cabal we're going to run it by saying something like, I can literally just say Cabal run, or I can say Cabal exec, and then the name of the thing I want to run. So I think Cabal run also works. Cabal run is nice because it actually will build it if it needs to be built, and then run it. So we can just say Cabal run. All right. Any questions so far? Obviously, feel free to interrupt with questions. Happy to try other stuff or whatever. So let's see. What is the next thing we can do? So first, let's think about like, what if I wanted to print hello Haskell, and then print another message? We'll start very simple. Like if I want to do something besides just print one thing, let's say I want to print two things. I can say put Sterling, some other message, right? But how do I combine these? Right, that's the question. So for that, we can remember that, I'll talk a little bit more about I/O in a minute, but we can remember that the other day that I/O is applicative. So we can use any applicative things with I/O. So in particular, we can use like, remember there was this thing that said like, if you have an FA, an FB, then it combines them to get an FB. And this is another big break. So what's the difference between, like, why is this different than just ignoring this first FA entirely and then just returning an FB? Okay. Well, here's another good example of why. Because in this case, right, put Sterling hello Haskell has type IO unit. Right? The value it returns is unit, which is this completely uninformative value, right? The point of it is that it does something, it has an effect, it prints something on the screen, and then when it's done, it returns unit. We really don't care about that unit, because it doesn't tell us anything at all. It's just like when it's done, it has to return something, so it returns a unit. So, if I use this operator to combine, right? If I was completely ignoring this first argument entirely, then it just would throw it away and it would only print the second message, right? But that's not what it's doing, right? It actually runs that first thing that prints a message, and then it ignores the unit value that it returned because we don't care about that. And then it goes and runs the second thing, and then returns whatever unit value that gives. So, so now it prints out both messages. Okay. Okay. So let me talk a little bit more about what this I/O thing represents, because this is it's worth thinking carefully about how this works. So a value of type IOA, it's like, think of it like, I like to think of it as a recipe, or, right? Think about like a recipe for a cake. This is the analogy I like to use. It's just like it's some instructions written on a card, right? It doesn't contain a cake. It's just a piece of paper with some instructions on it, right? If I want a cake, but it's kind of like a promise. It's like if you follow these instructions, stuff will happen. Your oven will get hot. You'll use up some flour. Other things will happen, and then at the end you will have a cake, right? So I have to actually like execute the instructions to get a cake. But also, just having a recipe doesn't cause anything to happen, right? I can have a recipe. I can give you the recipe. You can like make a copy of the recipe. We can do all those things, and we're just dealing with recipes. We're not like, the oven's not getting hot or anything, right? So in the same way, a value type IOA doesn't actually, like that value itself is kind of just like a recipe. It's really like a program, like an imperative program. But it's like an imperative program that we can kind of like pass around, we can make copies of it, we can store it in data structures, whatever. But like, to actually make that stuff happen, we have to execute it. And so ultimately, the only I/O thing that ever gets executed is the special thing called main. And the Haskell runtime system actually takes that thing called main and it executes it. And if we want, whatever we want to happen, we basically have to compose it all into one big I/O action that will then get executed. So anything that kind of gets included in there, right? And we can see like here, this is one way we can combine two I/O actions into one, right? We say, all right, I've got this one, and I've got this one, and I want them both to happen, so I combine them with this operator. Right? It's kind of like if you have a recipe for, a cake, and the recipe, or just like the actual cake part of the cake, and you have another recipe for frosting, right? You can kind of put them together into one recipe that says, first make the cake, then make the frosting, right? And now that's like one recipe, and it's just ignoring the output of the FA.
And since it's not really an output, it still affects it.
Right. So going with the analogy here, if this is like a recipe for cake, and this is so you wouldn't want, if you were, what I said about like combining a cake and a frosting, you probably wouldn't want to use this operator because the output would be a cake, and you want the cake probably, right? Maybe a better analogy would be like, let's say you have a recipe for, how to preheat your oven, right? And it tells you like, well, first you push the on button, and then you push this until the number says what you want, and then you wait until it beeps, right? And then the output value is like unit, because it wasn't actually to make something, it was, the purpose of it was to cause some things to happen, right? And you can combine that with a recipe for cake, right? Because you're like, first you have to preheat the oven, so follow these instructions. Ignore the output, it just caused some things to happen, right? And now you can make your cake because now your oven is hot, right? That's the same thing that's going on here, right? This is saying like, we're gonna put some stuff on the screen, kind of like making the oven get hot or something, right? Something happens, then the value that we actually return is just unit, because there's no value to return. It's just kind of like, yeah, I'm done. It's just kind of telling us that it's done, and it doesn't really give us an informative value. So we can ignore that value. Does that make sense? There's this distinction between the value that gets returned and the things that it causes to happen along the way, right? So this ignores the value that gets returned, but it doesn't ignore the effects or the things that it causes to happen. So we can combine recipes into bigger recipes. I'll say when executed, it causes, or it can cause things to happen, which we call effects, like printing to a screen, reading from a file, sending data over the network, etc. And finally, returns a value from type A. Combine recipes, bigger recipes, store them in data structures, etc. It's really, another way to think of this is, a value type IOA is a first-class imperative program. If I had more time, I could probably go on for a while about like why does Haskell do things this way. Very, very briefly, the idea is that in say Java or Python, if I have a function that returns an int, then it's definitely going to return an int, but it might also like print something on the screen. Right? If I call some function and it's going to return an int, it could also cause stuff to get printed or whatever. So why doesn't Haskell do that? Why doesn't Haskell just say, well, a function that returns an int could also cause stuff to get printed on the screen? A very brief version is, there's a few reasons. Number one is, because Haskell is lazy, that would get very, very confusing. Because when the stuff actually got printed on the screen, or even whether it got printed on the screen, could depend on like whether you ended up needing the output of that function or something. Because it might just ignore it entirely if you didn't need that, right? And so in Java, you know precisely, like when I call this function, like it's first going to completely evaluate the argument, and then it's going to pass that to the function, right? It's strict. So you can predict exactly what things are going to happen when, right? If Haskell kind of mixed arbitrary printing stuff to the screen or whatever with evaluating things, it would be impossible to predict, because, it's like, well, it doesn't end up needing that value, and the compiler would be free to not evaluate it if it could figure out that it wasn't needed, stuff like that. There's some other reasons, but that's the biggest reason. So this IO thing is basically a way to say, combine I/O values kind of makes explicit the order that we want things to happen. Like that. So we can actually have control over that, where we wouldn't have control over it if we didn't kind of have a separate type to keep track of it. That's the very short version. If you're interested, you can find much longer explanations. Probably even some that I gave. Like if you go find videos that I made last time I taught this course, I think I talked about this more. But okay. So here's what I want to do next. I want to print out, let's just, I guess there's two things I want to do, and they're both going to need something else. So one thing I wanted to do is to be able to pick a random number. And to do that, we're going to need to use another package. Use a random package. I also wanted to be able to then, to start, let's just have it print the number that it picks on the screen. Of course, ultimately, it won't print the number, you have to guess it. But to start, we'll just have it pick a random number and then print it. But I claim that given the tools that we have right now from Executable, we can't do that. And let me see if I can convince you why. We're going to need something else. So there is a function called print, or we'll just say print. Well, we have print string, right? And we have show that can convert an int into a. So for example, we have there's a function called read. Has this type. Yeah. So let's think about what this type means for a second. It's basically saying, okay, this is an I/O action. So it's gonna, in particular, it's gonna wait for the user to type something on the keyboard, right? And then it's saying I can return any type you want as long as that type is an instance of the read class. And the read class basically gives us a way to convert strings into that type, right? So once it knows what type we want, like if we said we wanted int, and it's like, okay, I'm going to wait for the user to type something. Whatever they type, I'm going to convert it to an int. I can return that int. Okay. And then we also have get line. You could use that doesn't try to do any conversion. It just waits for the user to type something, and then when they hit enter, it returns whatever string they typed, right? And then we also have, we have put string, of course. It takes a string and I/O unit. I mean, it causes the string to get printed on the screen. It doesn't actually return any interesting value. So the question is, like, even forgetting about read line for a minute, just how could we combine these two, like to just ask the user to enter something and then echo back to the screen whatever they typed. Okay. If you think about the, we have like these kinds of, this kind of thing we can do with Executable. There's not really a way to do this. So, for example, I might say, all right, well, I want to, I want to combine these, get line and put string somehow, right? So maybe, I could use this kind of pattern, and I just have to figure out what function do I want to combine them, right? But actually, so okay, get line is going to return a string. So maybe we'll make a function that takes a string and something else and does something. And then put string, well, actually, this doesn't even really have the right type, because put string, like this pattern, right? Both these things would have to be an I/O something, and then we can combine them using this pattern to get another I/O something. Put string is not an I/O something; it's actually a function that expects a string, right? So I have to give it a string here, right? But the string I want to give it is whatever string this thing returned, and there's no way to do that because, this function here kind of can get at that string that this returns. But I don't have any way to like give that string back over to this thing. I have to come up with what string I want to give here, you know. Like I could do this, and this would work. But the point is, like, I had to decide what string to print out, like right now, before I ever ran this thing at all. So this works okay as long as I know exactly the things I want to do and they don't depend on each other, right? Like if what I want to do here doesn't depend on what happened over here. It's just like I independently chose some things to do, and I want to do them all and combine their results. But I can't, so I'll just say the above pattern works if we know up front exactly what actions we want to do, and we just want to combine the results. But it does not give us a way to let later actions depend on the results of previous actions. And that's obviously a pretty big limitation, right? I mean, like, pretty much all programs ever, if you like prompt the user for something, you want the rest of the program to be able to depend on what they input. Otherwise, kind of what's the point of prompting the person? Now, there are a lot of situations where this is perfectly fine. For example, a lot of languages that you might want to parse, you know exactly kind of what the options are going to be when you're parsing it up front. You don't need to be like, oh, first let's see what is actually written in the beginning of the file, and that's going to tell me how I'm going to parse the rest of the file. They do exist, but a lot of times that's okay. But obviously, if we're doing this kind of input and output, it's not going to be that. Any questions at this point? I want to make sure this makes sense. Yeah.
Does readline always like take in a string? Like even if you type like the number 6, is it changed into a string?
What do you mean? Readline or getline?
Readline.
So readline, I mean, of course, fundamentally, when you type something, it reads it as a string first. But then it doesn't return that string to you. Whatever type you say that you want as output, it tries to convert the string to that type. Now, if you type something that's not a valid, you know, if I wanted an int and I typed in like XYZ, it would crash because when it tries to convert it, it doesn't work. So this is not actually a very like safe function. This is like a quick and dirty function. If you just, you know, you wouldn't use this like in a production system. You would have some like more robust way to deal with faulty user input. But for our purposes, it'll be fine. Does that answer your question? So eventually, right, we will use this because we'll want to say, all right, you know, guess a number, and we'll just use that. But just for now, I even want to just let the user type any string and just print it back on the screen. So, any other questions about this? I want to make sure this makes sense. Why we can't yet do that. So right, the point is that applicative, the fact that I/O is applicative is nice, but it doesn't give us the tools to do this what we want. So there is another function that gives us exactly what we want. And it is more general. It doesn't only apply to I/O, but for now we'll just think of it in terms of I/O. Okay. There is another operator that gives us exactly the ability we want. And I will write it down with its type, and then we'll spend a little bit of time thinking about how the type works. So I'm just going to That's not the most general type that this has, but it is certainly a valid type for this thing, right? We can use it on IO specifically. So if you look at these, like, they're pretty similar, right? The difference is that this thing isn't just an IOB, it's actually a function from A to IOB. So what does this mean? It says, okay, essentially, this is also combining two IO actions into one, right? We give it an IOA, and if you squint, we kind of give it an IOB, and we get back an IOB. But, right, this is actually a function from A to IOB. So this says, once you've executed this, and it returns an A, we can feed that into this function in order to decide what IOB we want to do next. Right, so this function says, we're going to decide what IOB we want to do second, depending on what A got output by the first one. Okay, and that's exactly the ability that we need for later things, like what we actually want to do for later things to depend on the results of previous things. So, this is pronounced fine. There's also a way to choose what action to run second, depending on the output of the first action. Okay. You know, and you can see, like, for example, one function we could give here is the function that just ignores its input and always returns the same IOB. In that case, we're basically back to this thing. So this thing, if you have this, if you have bind, you could implement this operator in terms of bind by just always giving a function that ignores the A. Right? So you don't have to use the A, but if you wish, it gives you that power. So let's see how to use this to write the thing we want. So put that here. So please I'll just say put stir. So put stir doesn't put a new line after it, so I'll just keep the cursor on the same line. And then, right, I can chain these together, of course, because, like, you know, these two together make one IO thing, and then I could combine that with another one. And so what I want to do is, I want to say, I'll put this in parentheses. I want to first say get line, that's an IO string, and then I'm going to use this bind. And the thing that has to go here is a function that takes the string, which is whatever the user typed, whatever get line returns, and then it's going to return another IO something. So, we'll call it, we'll just say, we just want to print it out, right? Actually, we can say push. Okay. Actually, I'll call it simple, but we'll call it name, because that's what it's supposed to represent. Okay? So, right, the function I gave it is the function that takes a string and returns the IO action that prints out the message welcome plus whatever the string was. Right? So obviously, you know, what actually happens here depends on what the user types. So we can run this. Nope. What? Oh. Try it. It's like auto completing stuff and then like adding imports. Hello, Haskell. Oh, okay. I forgot a very important. You're like, what? This is probably good that we ran into this because some of you may run into this on a project. Like, why did it print out hello Haskell and now it's just sitting there would have expected it to print, please enter your name, right? So this is just due to a, oh, see, there it is. Basically, by default, output is line buffered, meaning it would be very inefficient if every single time you wanted to output anything, it like sent it to be output character by character. Because every time you want to output a character, it's like you have to interrupt your program, you call the operating system, you tell it, I want to output something on the screen, blah, 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 right? So what actually happens is every time you print something, it just saves it in a buffer. And then by default, every time you print a new line, it actually goes ahead and everything that was waiting to be printed out, it prints it all out. So here, we didn't print a new line. We just said, please enter your name with no new line. And so it's just like, well, I won't print it yet. I'll just wait. But that's not really what we want. So we can say H state. Import some things. Oops. So I'm just changing the buffering, so now it's just gonna, anything that gets printed out is just gonna instantly put it on the screen. Which is less efficient, but we don't care about that for an interactive user app, right? We might care about it if we were like printing a ton of data to a log file or something like that, but right. So obviously, right, whatever we put in here, we can print that out. Cool. Questions at this point? Yeah.
Could you have just changed let's or the name just let's or line?
Yeah, I could do that too. That would also fix it. It just means
It
that
just wouldn't type.
like when you start typing, you would be on the next line, which, you know, I just think this looks nice. And it's just, you know, you may run into this, and so it was kind of my opportunity to point this out, which often trips people up. It's not really a Haskell thing. I mean, this is actually an issue in a lot of languages might have this issue or have some kind of buffering setting to the output. So, yeah.
Like before you did that, if you would have just like typed your name. when
Yeah,
was
it would still
waiting,
work.
It
So we
would
can
all
actually,
type it on one
yeah, we can see what happens. If, like, it still works, just the output looks confusing. Yeah, it's just like, it just looks like it's in the wrong order. And like, if you saw this, you'd be like, wait, why did it do this why did it do this after this? You know, it's like, well, it didn't. It actually did them in the correct order. It's just that the operating system was like, you want to print that? Okay, that's cool. I'm not going to, I promise I'll get to it, you know. And then like, when you actually enter, that's when it's like, oh, maybe I should do that now. But, so like, yeah. Cool. Any other questions? So let's see. Let's add one more thing. We'll just be like, after we welcome them, maybe we'll ask them to enter a number, and we'll let them know what the number was. The code is going to be really ugly, and that's on purpose. Then we're going to see how to fix it. So, let's forgot to turn off Teams. So we'll say, all right, you know, after that, we're going to say, let's then after point is just like, okay, if all I know is like I have this operator and this operator to combine I/O things, and I guess I can just combine a bunch of them in a big long nested mess of parentheses. But like, it's like, okay, we first do get line, and then the function that we give it says we're going to take the name as input, and then do this whole thing after that, right? And that whole thing is composed of multiple I/O actions that I'm combining. It's like, well, first I'm going to print this, and then I'm going to do this other thing. This other thing consists of first printing something and then doing this other thing, and that consists of calling readline and then doing this thing that takes, the function that. So it's, and you can see what happens if I do like, it crashes, right? It's like I couldn't do it. Okay, so the first thing is that we actually don't need any of these parentheses. That's the first thing we can do to clean this up, because this operator is right associative, so it just will chain that, right? And then also this, we don't even need this parentheses here, because this operator, when you give it a lambda as the second argument, a lambda, when you parse it, it always extends as far as possible. So basically, when you say lambda name arrow, everything after that is going to be part of that lambda. And that's what we want, right? Because we want to say, take the name that comes out of get line, and then do all of this as like the next thing that happens after that. And even if there's like nested lambdas inside of that, like it's going to be fine. So, okay, we need these parentheses here around the put string, that string, but we don't need these. String out. Yeah. Okay, that works. And we can start doing things like, well, let's just add some. Actually, let's do this. We just start like adding some new lines in here, right? Because just to help us do it. Haskell doesn't really care about new lines, right? When it's parsing. So this works too. Okay, and we're out of time, but next time we'll see a way that I'll talk a little bit more about this. This pattern arose so much that people came up with a nice notation for it.